G'day there, you're watching the Aussie BIM Guru, and today I'm going to run through a tutorial in Dynamo for Autodesk Revit that deals with the final part of a 3-part series I've been putting together, which deals with creating views and sheets and then placing them automatically using scripts. So the overall workflow is that we've built a script already that can create floor plan sets from levels. We've built a script that can create sheets from Excel, and then the final step is to create a script that uses Excel to place those views on sheets automatically. So today we'll be focusing on that third part. So covered in this session, we'll be looking at the Excel data required for the script, how to obtain views and sheets from Excel in Revit, and then how to obtain a reference view position to tell the other views how to be positioned. Then we'll place the views on the sheets and set their viewport type as well using the script. Some custom nodes are required for this script. So a couple of them come from a package called Steam nodes, in particular ones that deal with viewport positioning and placing them on sheets. And then there's a package from the Archilab package called Get All Viewport Types as well. But without further ado, we'll get into actually putting the script together. So this is the version of Dynamo that I'm running for anyone that wants to follow along at home. And I'll just start now. So for those that have tuned in previously, basically the point we've got to is we've got a whole set of sheet views broken down by series, and then we've got a whole bunch of sheets also broken down by series, but we want to put all these views on their respective sheets. So I've placed one view on a sheet, so really all this view is being placed for is to have a reference for all the other views for how they should be positioned relative to a sheet space. It's important that all the views have the title block in the same position, because this is all relative to the same coordinate system in sheet space, technically. I've also set up an Excel table with one column containing all my sheet numbers, and the other column containing all the view names of the corresponding views that should be going on those sheets. I found this is usually the best workflow because it's quite easy to get this data already, given that you've probably got your sheet numbers in your previous table you used to generate all the sheet properties, and the view names are quite easily extracted from Revit. If you do want to extract them, usually the most efficient way is to create a view list and filter it down. Go up to File, Export, scroll down to Reports, export the schedule. And you can just go to your folder, save as delimited text. And you can set your field delimiters, usually a tab is fine. Typically then in Microsoft Excel, you would go File, Open, navigate to that particular file, so Demo, and change it to All Files, and open your view list, choose delimited, and make the tab your delimiter. And that would be your data, so essentially they are your view names. So that's pretty much how I've processed that data in this case. But what's important is to have that single file where you've got the views and the sheets together, because we'll use this to process in Dynamo. So we'll get started in Dynamo now. I've probably been talking too long. Okay, so pretty much the destination node that we're trying to reach with our data, I'll just go to manual mode before I forget, and we'll just save somewhere to demo, and we'll just save demo. So our destination node is place views on sheets existing. Place views on existing sheets. There is another one in the same package that doesn't seem to work the same way, which is place views on sheets. So I've typically been using this node. So ultimately this expects a list of sheets, a list of views, and a list of positions on those sheets for where we should place the views. So what we're going to do is start with Excel data. So we're going to import Excel. So we'll start with that. We'll get a file path and then a file from path. For those that saw the last tutorial, this is pretty much the same way I start off nearly every single script that uses Excel, although I do have a little starter project that I've got that I typically start that contains the full shell of what you would need to start with an Excel file, because obviously there's a lot of repetition in putting this part of the script together. So sheet name, we need a couple of booleans, or we do want to read them as strings so that numbers aren't interpreted as doubles or numbers. Dynamo calls numbers that are whole doubles instead of integers. Okay, so that would get us our Excel file. So we'll just browse to our data. So sheets to views. Okay, so if I just do a run on that, you'll see that I get a table currently set up with 2 rows. So what we want to do is remove our header row. So we're just going to make an integer slider. This is basically part of the fundamental portion of the script relating to Excel as well. Because usually you'll want to drop that item. So I'll drop the first item from that list. And I'll just transpose that list after that to swap the columns and the rows. I'm doing this quite quickly because I showed this in my previous tutorial. And you'll see I've got a list which is basically all my sheet numbers and all my view names. So there are a couple of ways to get views and sheets from this point. Usually what I do at this point is say, to get my views, I'd go all views of type. So get views by type. I think it's get all views. No, sorry. Get by type. There we go. And then we can get a drop down for view type. There are some faster nodes that can be custom nodes, but I try to minimize the number of custom nodes I use in scripts where possible, unless it saves a lot of time. So there you go. So we can get all floor plans in this case. So if I run that, you'll see I'll get a full list of all the floor plans in my document. I then want to get the names of all those. So we'll do element name. And if I run that, you'll see we end up with ground, level 1, etc. So obviously these aren't all the floor plans we want. So we want to basically make a list that contains those floor plans based on the order they appear in Excel. So we're going to do a get item at index to get our views. And we'll get items at index 1, because our views are in our second column. And we'll basically go find item, no sorry, index of that item in the list. So where does this occur in that list? So in that list, where do these occur? Which indexes? And now you can see the positions that they all occur in that respective list. And then we can do a get item at index to get items from the view list by the index that they know they should be. And basically what this does is it builds up a list of floor plans as they appear in that Excel list. So obviously your list needs to be perfect. You can't have a typo because it will fail to find it in that case. But you can see there that basically we've got a matching list. So you can see we've got 53 floor plans and 53 items from Excel. So that's pretty much how you can do that. The process for getting sheets is very similar. So we'll actually just take majority of what we just did here and copy it up, and we'll just swap out a couple of basic nodes. So we're going to do sheet name, sheet number, because we've got our sheet numbers from Excel, and we're basically going to be looking for those sheet numbers in item index 0 instead. And we're going to do get by category. In fact, actually, I think there's a node that gets all sheets in projects. I might choose that instead. Maybe not. Maybe not a basic one. So we'll just do category by name. All elements of that category. There it is. It's funny that it doesn't always come up right up the top immediately. And then we'll just do a string to get sheets. Cool. So if I run this, we should likewise be getting, index of sheets. We should likewise get a list of sheets that will correlate to the order of those sheet numbers. So you can see that it's found the successful match for those respective sheets. And that's quite simple. So at this point, we do have the ability to say these are our sheets, these are our views, but we need points. So I'm just going to freeze this. And what we do now is we go and reference a sheet that has a view placed on it. So this allows you to select any sheet from the project. So I can say I want to refer to ground floor, and I want to get all the viewports on that sheet. So get viewports on sheet. There's only one on the sheet at the moment, but if there was, say, some legends or something like that on there, you would actually want to pick a particular view out of that sheet's views. So I'd add an integer slider here, starting from 0. So we'll just say we want item 0 by default. And we do a get item at index, because we only want to reference one view at this point. So we'll take that list of viewports and get item at index. Okay. And at this point, we want to use a viewport center. So get box center. And it's interesting that this actually requires a list to be fed into it. So if I fed this item in, it actually gives me a null from what I've experienced. So I actually need to turn this into a list before I feed it in, even though it's one item, because the node is expecting a list to be given to it. So this is one of the nodes from Steam nodes. And now you'll see that will get a point. And typically you can see there's a point appearing in 3D. I typically turn off preview for those things because we don't really want to see that point. And there you go. So at this point we have one point that we could feed in, but we actually need to make a list of points equal to the number of items. So what we can do is count the number of things we're dealing with. So we could take this and say, how many of these are there? So if I run this, you'll see it'll give me a number, 54. And we can make a list of repeated item. And that will basically let us take an item and repeat it a certain number of times. And there you go, you see we have 54 points basically, but we do need to flatten that list because you did see that there was actually nesting occurring in that list. So we basically need to do this. I'll turn off preview again. Each time those points get fed through, they'll preview. So there you go, so we have 54 points. So at this point we can feed this in. And then the last thing that we do need to do is make sure that the viewport is being set properly. So we do need to set the type of the view, set parameter by name. And if you're ever not quite sure of the parameters that you're trying to find of an element, you can always find another one and interrogate what parameters are in there by using the parameters node. And if I just feed this in here and run it, you'll see that we'll get a whole bunch of properties out of this element that we can check. And in this case, you'll see that this is where it says it's type. So that's what we want to get out of here, but we're going to check the views properties instead. So we'll just get that first view there and see what properties there are and where's the one that we're looking for. And I believe it's under type. Typically, type, floor plan. I'll just cross-check in my final script and just make doubly sure which node that is we're looking for. Just because I'm not 100% sure on the name of it. So I did build the script already and I had to do some experimenting. No, it is type, so it's type. Okay, great. Because once you create those views, it actually sees them as viewports, not views. So we can set the type of the viewport instead. So if we do a set parameter by name, and we feed in our viewports, and our parameter we're setting is type, then that would be sufficient for us to feed in a viewport. But how do we get the viewport? So this is where we need a special node from Archilabs called get all viewport types. And basically, if I run that node, you'll see that we get a list of all the possible viewport types, and we can from there get the name of each of those using element name, which is a really handy node. So if I run that, you'll see we can check the names, and we basically need to set up again a comparison node where we'll have an input. Let's say in this case we want to make them no title because we don't want them to have a title line. And we basically say, does it equal that? And it has to only be one of them because you can't have matching viewport names. And then you can see it's going to get us that index, and we just filter in a list by bool mask, or filter by bool mask. So we'll get that viewport by filtering out that true false condition, and our only true is no title. So we're basically pulling through that, but instead we'll get through the viewport type itself. And there you go. So this is something we can feed in as a parameter now into here. So essentially what we have now is a full script. So this would work. So I'll just show you it in demonstrated format. So in principle, what it should do is take each respective view and tell it which sheet to go on based on its properties. So if I just open up my sheets to views, we'll basically match these up and say put this on this, this on this, this on this, this on this, because we're basically turning these into sheets and views in Revit, or changing the references to actual sheets and views. Okay, so if I save this, and I'll just minimize this a little bit, and we'll just run this here. So you can see at the moment I've only got my reference sheet. So what we'll do, I'll just double check the lacing on here and make sure we're lacing this okay. So we need to do longest for this one, just to make sure it applies this to every single one. Other than that, I think we're in business. So if I run this, it can take a little while just because it's doing a lot. It's moving a lot of views onto a lot of sheets. It shouldn't have to generate the sheets themselves, so you shouldn't have to worry about the graphics reloading for each of these. But overall, you can expect it to take maybe about 0.1 of a second per view, possibly. But you can see there it is. It's successfully placed every single view on every single sheet, and it's positioned them the exact same way as my reference sheet, and it's set its viewport type to none as well. So very powerful, saves a lot of time. A game changer for things like tower design, where you've got multiple plans all positioned the same way. If you had a project where you've got particular zones that are all positioned a little bit differently, you can do separate runs of the same script, or you can configure your script to recognize things like scope box correlations to view names to sheet names, so that you can semi-automate placement depending on how things are named in relation to each other. But it's a little bit more complicated. But I thought maybe it might be worth just showing the workflow again from start to finish using these 3 scripts that we've built, just to show that it works as a process. So I've set up another demo model that's right back at the start before we even began. So we don't have any views, we've only got the base views, we don't have any sheets, and we obviously can't place anything because we don't have anything to place. So what we'll do is we'll run Dynamo Player. So I'll just save out of this. And I've basically packaged up the scripts for Dynamo Player in here. So I've got one for creating views, one for sheets, and one for moving them. So if I run Dynamo Player, and we'll just navigate to that folder. So these are basically our 3 steps. So if I just expand this, so let's create our view series. So this will take a little while, so I might skip over a couple of steps, but I'll go between each script at the very least. So the properties take a little while to open on some scripts. It would be nice if they were a little bit quicker, but I guess in principle what it's doing is booting up the whole script. So we're going to go general arrangements, 8mm head, 10__GA. I'm going to have to name these very particularly because my Excel files have been built to anticipate explicit naming. And there you go. So that's our last set being created right now. So overall, that process took probably about just a bit under a minute. And a majority of that time was actually me typing in these inputs. So there are probably smarter ways I could set that up in future. We'll go to create sheets, the second step. We're pointing to our sheet list 1 already from sheet 1, ignoring our header. So we'll just play that. And this should set up all our sheets for us that we'll place our views on for our 3rd step. This step shouldn't take too long either, usually probably about 10 seconds or thereabouts. Should be coming up on shortly. Come on, almost done. Usually it's a bit faster than that. Must be thinking because I've just run another script, so it must have had to clear out some data, I think. Cool, so that should set up our sheets, which it did not. Okay, that's a bit odd. Alright, let's try that again. Oh no, actually, okay, so that did set up our sheets, but it sets them up as placeholder sheets. So at this step, we'd have to go in and place all our sheets from there. Okay, and that's all our sheets ready to go with all their properties populated. And the 3rd step is to move views to sheets. So we'll just again open the properties, cross-check that we have sheets to views, sheet 1, ignoring the header. Our view type is floor plan, so if we were doing ceiling plans, we'd run a separate script. And at this point, referencing sheet is just the one that we want to take the positioning from. So what we would do is go to GA ground floor, or whichever view is your reference view, place 1 view the way you want it to be sitting. It's reference 0, and we want to use no title as our viewport. So we'll play that. And essentially this is the final part. So you can see overall, I've been roughly timing myself, and I think we're going to come in just under a minute and 40 seconds. to place about roughly 50 views into Revit and all the sheets and place the views on there. So obviously, compared to doing it manually, an extremely efficient process. So if we just go down to our sheets, and there you are, we've set up all our sheets. So you can see the power in just that process for very repetitive view placement. So there we go. So pretty cool. So there we go. So we've seen the overall workflow. We've seen that it works. It takes about a minute to do 50 sheets. So hopefully this is a script that you're able to build as well and test. So if you missed the first two parts, feel free to go back and view them in order. And thanks for watching today. I hope you got a lot out of it. If you've got any comments, feel free to leave them down below. Any queries, I'm always happy to help. And thanks for watching. I'll see you at the next one. Take care. Bye.